Hello guys, today we are going to solve road preparation and it's a CSES platform है ना and it's a graph problem. Okay, CSES is the best platform यार for the clearing concept यार. If you are not solving it now, then please start to solve in CSES है ना. It will help ना to build your concept. Okay, then we will see the question road preparation. Problem statement is like this that there are n cities and m roads. There are m cities and m roads है ना. And unfortunately the condition of the road is so poor है ना. The road is so poor means the road is pathetic है ना, means the road is broken maybe है ना, therefore they cannot be used है ना. What is your task is to repair some of the roads है ना, so that there will be a decent route between any two cities. Means basically roads are broken है ना, roads are damaged and you have to repair some of the roads है ना, so that there will be a route between any two cities है ना. And you have to return ठीक है. What you have to return minimum cost है ना, minimum cost, minimum total reparation cost है ना. And if it is not possible then print impossible ठीक है. And the test case is like this that there are n roads है ना and n cities and m roads है ना. तो n is equal to 5 means 5 cities ठीक है, and m is equal to 6 means 6 roads ठीक है. And what it is given, it is given there is a s between 1 to 2 with distance with cost है ना, with reparation cost 3 ठीक है. And there is also an s from 2 to 3 with reparation cost 5 and 2 to 4 with reparation cost 2, then 3 to 4 8 cost, 5 to 1 7 cost, and 5 to 4 4 cost. And just draw a graph here, just draw a graph using it. And then it's a 1 to 2 3 and 2 से 3 ठीक है, 5 2 से 4 2 से 4 ठीक है, 2 से 4 with distance 2 ठीक है, है ना. 4 से 3 है ना, 3 से 4 3 से 4 with distance 8 ठीक है. 5 to 1 है ना, 5 to 1 ठीक है, 5 to 1 with distance 7 and 5 to 4 है ना, means this is है ना 4 ठीक है. तो basically you have to repair है ना the roads and the cost should be minimum as possible ठीक है. And if there is not exist any road between two cities then print impossible. Okay, then here what can we do, just think about it है ना. What can we do, what can we do, just if I remove है ना, if I remove some of the edges then will it affect in the result, because I have to take means I have to basically draw a road है ना between two cities. I mean there should be a connection between one cities to two cities, doesn't matter it is directly or it is going with someone else edges है ना, with someone else edges है ना. Just suppose I have to go to 1 to 2 है ना, then there should be a direct edge, there should be a direct 1 to 2 edge. And another possibility is what, first it will go 1 to 3 then it will go 1 3 to 2 है ना. Then there is a possibility of going traveling 1 to 2 city है ना. तो there may be a s direct s or maybe means another vertices है ना, there can be an s from another vertices. Okay, then I have to repair the roads with minimal cost. And if there is a possibility of not reaching any cities means there is no roads है ना between reaching cities है ना, then print impossible. And what we can do यार means basically I have to minimize the reparation cost. So यार we all know यार, first what will we do, we will take na smaller distance means smaller reparation cost first, then of course we will use priority queue है ना, because priority queue है ना for minimum heap है ना. First what here priority queue will do, it will just take है ना, it will first take है ना minimum distance ठीक है. Then what I will do, I will create a priority queue है ना, and first I will put it है ना zero distance and one node ठीक है, zero distance and one node. And I will make a visited array, I will make a visited array 1 2 3 4 5, and I will here write cost है ना, I will here write cost ठीक है. First what we will do, it will iterate है ना, it will iterate 1, है ना, and it's a यार means undirected graph, okay, means you can go from 1 to 2 city and also from 2 to 1 city, ठीक है. तो first I will remove one node from the priority queue, है ना, it will iterate into 2 and 5, ठीक है, with distance 3 2, ठीक है, and with distance 7 it will go to node 5, है ना. Then we will mark one as a visited, it is visited, so I will cut it, and I will just put the cost is 0, okay, cost is 0. What we will do then, है ना, priority queue will take minimum element, है ना, minimum element is 3 or 7, of course 3, है ना. Then it will cut 3 and mark 3 as a visited, and I will, sorry, node is 2 na, node is 2, sorry, node is 2, distance is 3, है ना, distance is 3, sorry, reparation cost is 3 and node is 2, ठीक है. Then 2 will be visited, 2 will be visited, not 3, okay, and the reparation cost is 3, then I will add 3, ठीक है. 2 will iterate, है ना, 2 will iterate from 2 will iterate to node 3 and node 4, ठीक है. With cost 2 will go to node 4, and with cost 5 it will go to node 3. It will not go to 1 because it is already visited. It will not go to 1, it will not iterate to 1 because it's already visited. It will only iterate to node 4 with reparation cost 2, and it will iterate to node 3 with reparation cost 5, ठीक है, खत्म. Now which is a minimal, 2 is a minimum, है ना, 2 is minimum reparation cost, है ना, node is 4. Then I will mark 4 as a visited, and I will add here 2. I will add here what, 2, है ना. अब 4 node कहाँ जाएगा, where will iterate this 4 node 4, okay. 4 will iterate to 2, but it will say that 2 is a visited, so we can't go here, है ना. 4 will iterate to 3, 4 will iterate to 3, ठीक है. तो it will go to with distance 8 node 3, है ना. 4 can also iterate to 5, 4 can also iterate to 5, and it is not visited, so it will iterate 5 with distance 4, है ना. I have already marked 4 as a visited, है ना. I have added 3 plus 2, है ना. Now which is the minimal, minimal is 4 5, minimal is 4, है ना, 4 8 5 7, minimal is 4, है ना. Node is 5, node is 5, I will add here 4, है ना, I will add here 4 distance, है ना, and I will mark 5 as a visited, 5 as a, this is the node ना, 5 as a visited, ठीक है. Where 5 can iterate, where 5 can iterate, 5 can iterate to 1 which is already visited here, ठीक है. 5 can iterate to 4 which is already visited, so it will just pop out, है ना, it will just pop out from priority queue, है ना. Then now which is the minimal, 8 5 7, of course 5 is the minimal, and then 3 is a node, ठीक है. Mark 3 as a visited, I will add here 5, I will add here 5, ठीक है. And this is the 3 node, 3 will go to 4, 4 say hey I am already visited, 3 will go to 2, 2 will say I am already visited, है ना. Then it won't go, है ना. Now it will just pop out, it will just pop out. Now 7 is a maximum, means 7 is the minimal in the priority queue, है ना. It will just take out from the priority queue, and notice the 5, 5 will iterate to 1, once I am already visited, 5 will iterate to 4, 4 will say already visited, है ना, it will just pop out, है ना. Similarly for 8 or 3, है ना, node is the 3, है ना, 3, this is the node, 3 will iterate to 4, 4 will say I am already visited, 2 will say I am already visited, है ना. So it will just pop out, है ना. Then what is the cost now, 5 for 9, 9 to 11, 11 3 14, है ना. What is the cost, cost is 14, cost is only 14, cost is 14. तो आंसर क्या हो गया, आंसर इज 14. आई विल प्रिंट दिस कोस्ट, है ना. नाउ वी विल सी द कोड ऑफ इट. आई होप concept is clear, concept is clear. What is the basically concept, है ना. I have taken a priority queue of minimal, है ना, of minimum heap, है ना. First minimum reparation cost will take out from the priority queue, है ना. Then I will take a visited array, I will mark it as visited, है ना, and I will just iterate into the iteration, है ना, from the node I will iterate, है ना, to its adjacent node, okay. How I will make a graph, I will make a graph of it. First what will take, we will take, है ना, means basically I am showing you a code, है ना, and I will explain it there. As you can say, है ना, this is the problem statement, है ना, CSES problem set road preparation, okay. This is the road preparation, and I will show here, है ना, I will show you, just wait a minute, I will show you a code. It is basically a website of ITBHU, okay. I'm a student, I'm a third year student of ITBHU, okay. This is the code here. This is the code. And first, what will happen here? There is a n edges and this n edges, and I have taken the input m. Sorry, n nodes. I have taken the inputs m edges, and what we are doing here, we are just constructing a graph, from u vertices to v vertices. Okay, u vertices to v vertices. Okay, and there was a given ABC. There was a given ABC, and I have just taken the input of ABC, and I have constructed a graph from A to B, with a reparation cost C, with a reparation cost of C. But it will be undirected graph, so I will also have to write adjoint of B dot pushback A to C, There should be also B to C, edges with a reparation cost C, since there is an undirected graph. Now we have taken the input, what we are doing, we are just using priority queue of minimum heap, we are just pushing pq, as we have discussed earlier, pq I am pushing 0 and 1, it is basically a pair, of this is the distance and this is the node. 0 is the distance and 1 is the node, since it is starting from node 1, now we are just, it is the sum, sum is cost, total reparation cost. Okay, sum is total reparation cost. Since we have given the constraint 10 ka power 9, so we are using long long here, we are using long long here, we have constructed a visited array. Initially everything is not visited, then we are just will run while loop until pq is not empty, I have taken pq dot top dot front mean distance, and the node is pq dot top dot second. If node is visited, then I would not have to go ahead, we will do basically pop out, and we will continue, because if it is already visited, just see here, just see here, if it is already visited, if I have to iterate from 3 to node 4, if 4 is visited, then is there any need to go to node 4? No, of course not, of course not, because it's already visited. So what we are doing here, we are just popping out, and we are just doing continue, and if it is not visited, then we are going to down, some plus is equal to this, we are just add the distance, we are just add the reparation cost, and I will mark it as visited, and I will just pop out from the priority queue, and I will just iterate into it. I will take iterate dot first, means it is the node from U to V, and a U to V. It is going into the V node with a reparation cost of weight, and I've taken the weight. If it is not visited, then I am just pushing into it into PQ, weight or V, and if it is not visited, if anyone is not visited, then I have taken the flag equal to false, and if flag equal to false, then it is impossible, because if any roads, if any city is not visited, then of course there is not any road between these two cities, therefore we are printing impossible, else just print cost, that is sum here, this was only a code here. It was a simple one, you can say, hope you will enjoy, you will like it. Thank you.